So guys, we have established the force displacement relationship between internal movements and displacement. Okay. Now we will use the concept of joint equilibrium and we'll get the desired equation. Right. So let us first come to this joint B. Okay. So at this B point, it will look like this. Okay. We just made a small cut over here. Right. So here the moment is MBA. Okay. Here the moment is MAB. Okay. Opposite of this will act on this joint, which is MBA. Similarly, here the moment is MBC. So opposite of which will be acting on this joint, which is anticlockwise. So this is MBC. Okay. So for the equilibrium of the joint, I can write MBC plus MBA is equals to 0. Okay, because we are considering the clockwise moment positive, so at the joint the moment are anti-clockwise. Okay, so that's a negative sign. So you can write MBC plus MBA equals to 0. Okay. So first equation will be formed correspond to this equation. Okay, we will put the value of MBC plus MBA from these equations, right? So now let us put the value in this equation. So MBC is 0.824 theta B plus 0.412 theta C minus 0.274 delta D. I'm not writing actually there is EI also. This is 0.824 EI theta B plus 0.412 EI theta C minus 0.274. This is delta D plus 0.274 delta B. Okay. Plus, what is the value of MBA? MBA is, this is 1.1 EI theta B minus 0.463 EI delta B. Okay. So we need to add these two equations. So the value will be, this is 0.824 plus 1.1. This is 1.924 EI theta B. Okay. Plus 0.412 EI theta C minus 0.274 EI delta D. And this will be minus 0.463 plus 0.274. So this value is minus 0.189 EI delta B, right? So this is our first equation. So let us write this equation over here. This is (1.924) EI theta B plus 0.412 EI theta C minus 0.274 EI delta D plus or minus 0.189 EI delta B equals to 0. So this is our first equation, right? So similarly, we'll write the moment equilibrium for the joint C. So for I can write MCB plus MCD equals to 0. Okay. So if we put this value of MCB is 0.824 I'm not writing EI, okay. This is theta C, right, plus 0.412 theta B minus 0.274 delta D plus 274 delta B, plus what is the value of MCD? MCD is okay. This is MCD. So MCD is 1.142 theta C plus 0.571 theta D plus 0.571 delta D minus 0.571 delta B. Okay, so we'll add this thing. So this value is 0.824 plus 1.142. So this is 1.966 theta C plus 0.12 theta B plus 0.571 theta D and this is 0.571 minus 0.274. So this value is plus 0.297 delta D minus of 0.571 274. This is 0.297 delta B. Okay, so this is our equation number 2. So equation number 2 will be 1.966 theta C plus 0.412 theta B plus 0.571 theta D plus 0.297 delta D minus 2.297 delta B equals to 0. Okay. EI will be there. So this is equation number 2. This is 0.297, right? Now we'll write equation 3 will be formed, will be considered for equation number 3, will be considering this joint D. Okay. And again for joint D, the equation will be MDC plus MDE equals to 0. Okay, so MDC is 1.142 EI theta D plus 0.571 EI theta C plus 0.571 delta D minus 0.571 delta B equals to 0, and plus what is the value of MDE? MDE is 1.11 EI theta D minus 0.463 delta D. Okay, this is equals to 0. So if you add these two equations, the value will be 1.11 plus 1.142. So this is 2.252 theta D plus, I'm not writing EI over here. This is 0.571 EI theta C plus 0.571 minus 0.463. So this is 0.108 delta D minus 0.571 delta B, which is equals to 0. So equation number 3 I'll write over here. This is 2.252 EI theta D plus 0.571 EI theta C plus 0.108 delta D plus minus 0.571 delta B equals to 0. So this is equation number 3, right? Now we need to form the equation. There are basically 5 unknowns, so we need to have 5 equations. Okay, so 3 equations we have derived. We have formed the 3 equations. Now for the remaining 2 portion, we will use the concept of shear. We will writing the shear equation. Okay, so now let us think. At this point, there is a 10 kilonewton load acting. Okay, so we'll forming shear equation in this horizontal direction. Okay, so this is, here the moment is MAB, here the moment is MBC, and again here the moment is MDE, moment is MED, right? So to balance this clockwise movement, we'll be having one anti-clockwise couple in this direction, same in this direction, right? Now opposite of this, the reaction opposite of this, one force will act in this direction, and again one force will act here also, right? And the value of this force will be, this is a, let us suppose this is H1 and this is H2. Okay, so writing equilibrium, shear equilibrium equation along this x direction will result in 10 kilonewton plus H1 plus H2 equals to 0. Okay, so H1 is basically will be equals to MAB plus MBC over my 3.6. Similarly, H2 will be MDE plus MED over my 3.6. Okay, this thing we have already discussed, right? This couple will form a, these two forces will form a couple that will balance this moment. Okay, from that we derive this equation. Okay, now what we will do, we'll put the value of this MAB MBC in this equation and form our next fourth equation, right? So this is 10 plus H1 is what? MAB plus MBC divided by 3.6. What is the value of MAB? MAB is 0.55 EI. EI I am not writing EI. This is theta B. Okay, so if I'm not writing EI, this is 10 over EI, right? So this is 0.55 theta B plus MAB is, sorry, minus 0.463 delta B. Okay, so this is this plus, what is the value of MBA? 1.1 theta B minus 0.463 delta B, right? This is divided by 3.6. And first let us calculate this will be plus, what is the value of MDE? MDE is 1.1 theta D minus 0.463 delta D plus 0.55 theta D minus 0.463 delta D. This is divided by 3.6 and this is equals to 0. Okay. So now 0.55 theta D. Now let us first solve this expression. So this value will be 0.55 plus 1.1 divided by 3.6. So this is 0.458 theta B and this is 0.463 into 2 divided by 3.6. So this is minus 0.257 delta B, right? Now we will solve this expression. So this is 1.11 plus 0.55 divided by 3.6. So this is 0.461 theta D minus 0.463 into 2, 0.463 into 2 divided by 3.6. So this is 0.257 delta D, right? So this is plus 10 over में E, right? This is total is equals to 0, right? So this is our fourth equation. I'll write this equation over here. So 0.458 theta B plus 0.461 theta D minus 0.257 delta B minus 0.257 delta D equals to minus 10 over में E pi. Okay, so in this way we derive the fourth equation by taking shear along the x direction equals to 0. Okay, now 5 unknowns, 4 equation. Now next equation we will form, where what we will do, let's suppose this is our frame, right, and we'll produce this member like this. Let us suppose this is point 2. This is MAB, this is MDC, MCB, and this is okay. So what we will do over here, I made a cut at this point, at this A, and this just above this D joint, right? So the forces which is acting on this portion will be one. There will be one axial force here, and there all one axial force will be there. Okay. So basically, what we are doing is that by taking the moment equilibrium about O, we are eliminating these two unknowns. Okay, these two unknowns we are eliminating. We have already have this force. We can find this force is basically equals to, we already calculated this force, MAB plus MBA over my 3.6. This is unknown. Okay, this force will be equals to MCD plus MDC over my 3.5. Again, the moment by using the concept of moment equilibrium. Okay, this force we have calculated like this. This is MDC, this is MCD. So to balance this, we need some anti-clockwise couple. Okay, so this is, in this way, next shear equation we will be deriving by taking the moment about this A point, about this O.0. Why is it? Because we need to eliminate these two axial forces. Okay, because we need to eliminate these two axial forces. So now we need to find this distance, and we need to find this distance. Okay, so actually our figure is looking like this. This angle is 21.8. This angle is 30.96, right? This distance is 7.5. So if you use tan law, I can write 1030.96 is equals to this distance, this is let us suppose y, over में 7.5. Okay, so tan 30.96 into 7.5. So this distance is again 4.5. Okay, and this distance will be, this remaining distance will be, this is 3.5. So again, if you use Pythagoras theorem, 7.5 square plus 4.5 square minus 3.5. So this is 5.24 basically. Okay, so this length, this distance is 4.5, this is 5.24. Okay, so now I need to take moment about this point. Okay, so what, and here one 10 kilonewton load is acting, right? So I can write due at this point, oh, the moment will be clockwise moment, I will take it positive, anti-clockwise moment I will take negative. Okay, so this will produce clockwise moment at O, so MAB plus this force will produce anti-clockwise moment. I need to write MAB plus MBA over my 3.6 into, and this distance is basically 3.6 plus 4.5. 3.6 plus 4.5. This is 8.1. Okay. Plus, due to this 10 kilonewton load, there will be, this is negative basically anti-clockwise moment, and again anti-clockwise moment will be there. So I can write 10 into 4.5, right? Due to this force, the moment will be again anti-clockwise. So I need to write MCD plus MDC over my 3.5 into this total distance is 5.24 plus 3.5. This is 8.74. 8.74, right? And plus this MDC will be equals to 0. Moment due to these two forces will be 0 because they are passing through this O point. Okay, so this is our equation, right? So guys, final equation will look like this: MAB minus of, this is 3.1 divided by 3.6. This is minus 2.25 MAB minus 2.25 MBA, right? This is minus 8.74 divided by 3.5. This is 2.497 MCD minus 2.497 MDC plus MDC equals to 45, right? So this is 2.25 minus 1, this is minus 1.25 MAB minus 2.25 MBA. This is MAB clockwise This is anti-clockwise. This is 2.497 MCD. This is minus 1.497 MDC equals to 45. So we need to put the value of this MAB, MBA into this equation, okay? So MAB is point. I'll simply multiply this coefficient by this equation, okay? So my equation will be minus 1.25 into 0.55. This is equals to minus 0.6875 theta V, right? Okay, this is minus 4.463 into 1.25. So this is plus 0.578 theta B, right? Now again I multiply this coefficient by this equation MBA. So 1.1 into minus 2.25. So this is minus 2.475 theta B, right? And again this is minus 2.25 into 0.463. So this is minus plus 1.041 delta B. This is delta B. Okay. So again, this is again I multiply this coefficient by this equation MCD. MCD is this. So this is minus 2.497 into 1.142. So this is minus 2.85 theta C plus 0.571 into minus 2.497. So this is minus 1.425 theta D, right? And minus 2.497 into 0.571. So this is minus 1.425 delta D. This is plus 1.425 delta D. Okay. Again, I multiply this coefficient by this equation. Right. So this is minus 2.497 into 1.142. So this is minus 2.85 theta D plus 0.571 into minus 2.497. So this is minus 1.425 theta C. Again, no guys, this is 1.497. Okay, so 1.497 into 1.142. So this is minus 1.70 theta D, right? This is again minus 1.497 into 0.571. So this is 0.854 theta C, right? And this is minus 1.497 into 0.571. So this is 0.854 delta D. This is 0.854 delta B. This is equals to 45 over में EI. Okay, guys. So we'll add the coefficient of first theta B. So theta B will be minus 0.687 minus 2.475. So this value is minus 3.162 theta B. Then I'll add the coefficient of theta C. Theta C, this is theta C. This is theta C. So minus 2.85 minus 0.854. So this is 3.704 theta C. Theta D coefficients are, this is minus 1.425 and minus 1.70. So 1.425 plus 1.70 will be 3.125 theta D. Okay. And the coefficient of delta B is 0.578 delta B plus 1.041 this is delta B basically, plus 1.425 and plus 0.854. So this value comes out to be 3.898 delta B, right? And the coefficient of delta D is minus 8.54 minus 0.854 and here minus 1.425. So this value is minus 2.279 delta D equals to 45 over EI, right? So our next equation will be, this is equation number 5th. So this is 0.362 theta B minus 3.704 theta C minus 3.125 theta D plus 3.898 delta B minus 2.279 delta D equals to 45 over EI. So this is equation number 5, right? So we need to solve these 5 equations, which is, this is equation number 1, equation 2, equation number 3, equation number 4, equation number 5. Okay, we'll be using the concept of method of substitution to solve this equation. Okay, so now let us solve this equation. So guys, these are our joint equilibrium equation and shear equation. Okay, now we need to solve this equation, these 5 equations, to get the value of theta B, theta C, delta D and delta B and this theta C also, right? So this 5 equation, we will be using the concept of method of substitution. Okay, what we will do over here, from the first equation, from equation first, I'll find the value of delta B, okay, which comes out to be, this problem I have solved in my notebook. So I am writing this writing the direct value. Okay, so delta B comes out from this equation is 10.179 theta B plus 2.179 theta C minus 1.449 delta D. Okay, so this is the value of theta B, delta B, which we are getting from this equation. Okay, now what I'll do, I'll be putting this theta b delta b value in this equation number 2 and find the value of delta d. Okay, so putting delta b value in equation 2. Okay, by doing this thing, I'm getting the value of delta d is 3.59 theta b minus of 1.812 theta c minus 0.785 theta d is equals to, this is the value of delta d, right? Now we got the value of delta b and delta d. Okay, so next step is to put this value in this equation number 3, equation number 4 and equation number 5. Okay, by this way what we are doing is that we are reducing this 5 equation into 3 equations. Okay, so by doing this thing, by putting the value of delta b, by putting the value of delta b and delta d in equation 3, 4 and 5, the value which we will be getting is first equation. Let us suppose this is 1a. Okay, the equation will be, if I put the value of delta d and delta b in equation number 3, so I'll get the value minus 2.453 theta b, right, minus 2.367 theta c plus 1.51 theta d equals to 0. Okay, so this is our first equation. I termed it as first a. Okay, now first b equation will be, if we put the value of delta b and delta d in equation number 4. Okay, so the value will be minus this is minus 1.74 theta b, right, minus 0.76 theta c and plus 0.37 theta d equals to minus 10 over में ei. Okay, so this is now our equation number 1, and then this is the first b equation. Okay, now first c equation will be by putting the value of delta d and delta b in equation number 5. Okay, so the value which we are getting is 7.8895 theta b plus 19.11 theta c and plus 3.088 theta d equals to 45 over में ei. Okay, so now what we did over here is that we we have 5 equations, so we reduce into the 3 equations by using the concept of method of substitution. Okay, we substitute the value of delta b and delta d which we found from the equation number 1 and 2, and later we will put we have to put the value of theta b and delta b and delta d in equation number 3, 4, 5 and got this final equation. Okay, so now we will be solving these equation, and from this equation I'll get the value of, what you can say that the value of theta b, theta c and theta d. Okay, so the value of theta b comes out to be 9.27 over में ei, means clockwise. This is clockwise. Okay, this is clockwise rotation. Theta c value is minus 3.11 over में ei, right? And theta d is basically 10.176 over में ei. Okay, so from we got the value of theta b, theta c and theta d. Now we'll put this value into these two equations. Okay, So by doing that, the delta B comes out to be 42.77 over EI, okay, and delta D comes out to be 30.926 over EI, okay. So in this way, we have calculated the displacement, the value of the displacement, which is theta B, theta C, theta D, delta B and delta D, right? Now what we will do, we need to find the end moments. Now we will use this force displacement relationship, okay? We'll be calculating these end moments value with the help of this displacement, which we have already calculated, okay? So guys, we have used the concept of method of substitution because there are 5 equations, okay? So in calculator, we can't solve 5 equations, okay? So that's why we have used this substitution. We reduce this 5 equation into 3 equation, okay? This we can solve in calculator, right? So now let us calculate the value of end moments, which we will be getting by putting this value of this displacements into these equations. Okay, so I have already calculated the values. So MAB value comes out to be minus 14.704 kilonewton meter. Okay, MBA this value comes out to be minus 9.60 kilonewton meter. Okay, similarly MBC will comes out to be 9.60 kilonewton meter. Why? Because we have used, for as per the joint equilibrium equation, MBA plus MBC will be 0. Okay, from that equation we can find this MBC equals to 9.60, right? MCB is equals to 4.50 kilonewton meter. Okay, similarly MCD we can calculate with the help of joint equilibrium, so it will be minus 4.50, right? MDE value comes out to be minus 3.023 and MDC value is 3.023. Okay, the value of MED comes out to be minus 8.72 kilonewton meter. Okay, so these are the value of the end moments, okay, which we will be getting by putting these values into these equations. Okay, so now let us calculate. Now let us draw the draw the shear force diagram and the bending moment diagram for this frame. Okay, because that is the ultimate part and important part, because we need to design each member for maximum shear force and maximum bending moment. Okay, so now let us first come to this member AB. Okay, for AB, let us draw the let us show these how the moments are acting and end moments are acting on this frame. This is minus 14, this is anti-clockwise, so this is 14.704. okay, here again there is anti-clockwise movement and the value is 9.60. okay, MBC is clockwise, so this is 9.60. MCB is clockwise, so this is 4.50, right? MCD is anti-clockwise, so this value is minus 4.50 or 4.50, this is anti-clockwise. MD is minus 3.023, so this MDC is 3.023, so this is 3.023. This is minus 3.023, and this is again minus 8.72. Minus sign is basically showing whether it is anti-clockwise or clockwise, right? So now we need to find what are the forces, what are the shear force is coming on this member. Okay, to calculate that thing, what we will do over here, this is 14.704, this is 9.60, and this length is basically 3.6 meters. Okay, now to balance this couple, and there will be some axial forces also acting on this member, which I am not showing. Okay, so to calculate the shear force for this member, there is some unbalanced moment. Okay, unbalanced moment is net unbalanced moment will be anti-clockwise. The value will be 9.60 divided by 3.6. This is 6.75, and here also 16.75 will act. Okay. So at this portion, there will be a force of 6.75, and here it will act in opposite direction, which is 6.75. Okay. Similarly, if we come on to this column, this D column, the net moment will be again anti-clockwise. So 8.72 plus 3.023 divided by 3.6. So this value is 3.26, and again this value is 3.26, right? Okay, and these two values will be equal to approximate 10 kilonewton. Okay, these two forces, right? So now let us come to this member. Okay, this BC member. For BC member, for BC, this is 9.6 kilonewton meter moment. This is 4.50. Okay, so total moment will be in clockwise direction. To balance this thing, we'll have anti-clockwise couple, so the forces will act like this. Okay, so 9.6 plus 4.50 divided by 4.85. So the value will be, this value is 2.90, this value is 2.90. Okay. So at this point, there will be one force which is acting perpendicular to this member is 2.90, and at this point it is 2.90. Okay. Now for this CD member, for CD member, the moments are acting like this: 3.023, this is clockwise, and this is anti-clockwise. So anti-clockwise moment is more than clockwise moment, so we'll have net anti-clockwise moment. Okay, and to balance that anti-clockwise moment, we need to have couple in clockwise direction. Okay, so this is 4.50 minus 3.023 divided by 3.5. So this value comes out to be 4.22, and this is 4.22. This length is 3.5. Okay, so at this end the value is 0.422. Here the value is 0.422. Okay, so there will be some axial forces also in this member which I haven't shown. Okay, so basically we are talking about the shear force diagram and axial force bending moment diagram. Okay, axial force diagram we have already discussed in details for the previous problems. Okay, so now this is okay. Now we'll draw the shear force diagram for this frame. Okay, So for shear force diagram, our structures look like this. Okay. This shear force will consider positive. I'm looking from here. I'm looking from this side. Okay. This is our positive axis and this is our negative axis. Okay. Now shear, the direction which we assume for shear positive will be look like this. Okay. So if you come to this member, this force is acting like this. So it will be above this reference axis. So the shear force at this point will be 6.75. Okay. And it will go straight up to this here. And the value at this, it will come to 0. So this is basically positive shear force diagram. This value is again say 6.75. Okay. Now if you come to this member, negative shear force assumption will look like this. So this is equivalent to this thing. Okay. And this is above the reference axis is positive, below the reference axis is negative. So this is in the negative case. So the shear force diagram will start below the reference axis. It will again go like this. So this is negative shear force diagram. The value is 2.90, 2.90. Okay. Now for this member, for this CD, this is A, this is B, this is C, this is D, this is E. What are the direction which we have assumed, direction assumption we have already discussed in previous problems. Okay. So for this CD member, this it will represented by this is equivalent to this diagram. Okay, this assumption. So it will start from this above the axis. So again, this is 0.422. This is again 0.422. Okay, this is our reference axis. Okay, now again we will come to this figure. Okay, this is considered positive. This direction is considered positive. So it will be drawn like this. This value is 3.26. Okay, so this is our shear force diagram basically. This is the shear force diagram for this frame structure. Okay. Now this thing is done. Now we'll draw what will be the bending moment diagram for this frame structure. Okay. For bending moment diagram, this is our frame. This is A, this is B, this is C, this is D, this is E. Okay. We'll simply take the value of the end moments and plot on this frame, right? So again, this direction is positive. This is negative. We have already discussed this thing in details in previous problems. Okay. So I'm not going to repeat the same thing again and again. Okay. So now, this is positive, this is negative. The value of the end moment, this is 14.704. Okay. And we know that the bending moment is drawn from the compression side. Okay. So it will start from here. The ordinate will start from here because this portion is in compression. Okay, this is C, and this face will be in tension. So bending moment will be drawn from the compression side, right? And here you can see that at this end, this face will be in compression and this is in tension. Okay, so it will start from here and it will go like this. Right, this value is 14.704. This value is 6.75. No, not 6.75, 9.60. Okay, this is basically point of contraflexure. Okay, so now this thing is done. Now let us come to this BC point, BC member. Okay, for BC member, this if we consider this thing, this moment will induce compression here. Okay, this moment will induce compression at this side. This will be here tension, this is compression, this is tension. So bending moment will be drawn towards the compression side. Okay, so this is 9.6, it will start again from here, and somewhere the value will be, so this value is 9.60 and this value is 4.50. Okay, now for the member CD, this is compression side. This moment will induce compression this side, this side of this member, okay, at this face, and this will also induce compression at this point. Okay, so it will be drawn, this value, it will be drawn like this, and this is 4.50, and at the end the value is 3. So this value is 4.5 and this value is 3.023. Okay, now let us come to this DE member. DE member, this side will be in compression due to this end moment. This face will be in compression. So the bending moment will be drawn from the compression side. It will start from here. Okay, and here the compression will be this side. So the value is 3.023. So again, it will look like this. This value is 8.72 and this value is 3.023. Okay, so this is the bending moment diagram and the shear force diagram. Okay, so what we did over here is now we can find the maximum for which member the maximum bending moment what is the value of maximum bending moment diagram is coming for the each member. Okay, shear force also you can find, the maximum bending moment you can also find. Okay, corresponding to that bending moment for each member, you will design that member according with respect to that maximum value of bending moment. Okay guys, so guys, we will see the deflection diagram for this gable frame. Okay, so we'll draw the deflection diagram over here. So this is our frame. Okay, so as you can see that at this A support, okay, A support, the slope is 0, and you can see that this side is in compression. Basically, this side is in compression. Okay, and when it is coming to B, the theta B value is basically clockwise. Okay, so it will bend like this, and it will go like this. Okay, so you can see that this is basically tangent, this is reference line, and this is basically the tangent. So this is theta B value. Okay, and this is anti-clockwise, this is clockwise basically. This is delta B, which we have already calculated. Okay, now let us suppose if this is our reference line and theta B is clockwise, anti-clockwise over here, and you can see that this through bending moment diagram, this portion, this upper face is in compression and the lower face is in tension, so it will bend like this. Okay, and somewhere here at the point of contraflexion will have some point of inflection. Okay, so let us suppose this is our point of inflection corresponding to this point of contraflexion. Okay, this you can calculate. Okay, So you can see that this face is in compression. This is this down, this portion, this face is in tension. Okay, bottom of this member. So now, and you can see that here the rotation is basically anti-clockwise. So theta c is anti-clockwise over here, right? Similarly, let us come to this part, this CD part. So at CD, again it will bend like this. This is our reference line, and this is the tangent over here. So this theta is again theta d. This is positive, which is clockwise. Okay. This displacement is delta d, which we have already calculated. Right. Now let us suppose this is our reference line. So from here, this portion, you can see that this complete portion is in compression. Okay. So basically, this bottom face is in compression. You can see that this, through this bending moment diagram, this bottom face is in compression, right? So it will bend like this, basically. Right? Here you can see that this theta is basically, theta d is positive clockwise. Okay. Here this theta is anti-clockwise. Theta c is negative. Right? So this is the, what you can say that this is the, basically the deflection diagram of this Gable frame. Okay. As per the bending moment diagram which we have found, and also the displacement which we have calculated, whether the theta, where the theta is clockwise and anti-clockwise, that thing is most important. Okay. And somewhere here we'll be having the point of inflection in the deflection diagram, where the curvature changes. Right. So we have discussed this problem in detail. So if you have any doubt regarding any portion in the problem, you can write in the comment section. Okay guys, so thank you very much.